Hi everyone. In this video we're going to look at lines and angles and properties of parallel lines. We're going to talk about different angle pairs that are formed when you have two parallel lines cut by what's called a transversal. And we're going to go over a couple examples of how to find missing angle measures. Before we do anything though, we need to go over these two very important vocabulary terms. The first one is parallel lines. It's coplanar lines that do not intersect, meaning they do not cross each other. These are examples of two parallel lines. These additional arrows show that these lines are parallel. They will never cross each other, right? They will always be next to each other and never intersect. We can write this as L is parallel to M. This symbol with the two lines next to each other, this means parallel. It's almost like you take your equal sign and you're rotating it this way. We get parallel. So L is parallel to M. So you're either going to see this statement or you're going to see these two arrows that kind of tell you that those are parallel. The other vocabulary term we're going to look at is something called a transversal. It is a line that intersects two or more coplanar lines at distinct points. Here are our two lines. T is what we call a transversal, right? It's intersecting here and here on two different lines. If you had just had two lines intersecting, you would only have four angles formed. But now we're going to actually look at 8 different angles in those angle pairs. Before we continue, though, I want to point out this is what we call the interior, because it's on the inside of our two lines, and our exterior because it's on the outside of our two lines. When we have parallel lines, this is going to be important. So, first angle pair we're going to look at is called alternate interior angles. Right? If a transversal intersects two parallel lines, then the alternate interior angles, meaning they're on the inside, that's the word interior, inside of our parallel lines, on alternating sides of this transversal. So alternating, right? Inside the parallel lines, on alternate sides of that line. These are going to be congruent. So if I said to you angle 6 was 60 degrees, angle 4 would also be 60 degrees. They're alternate interior angles. Angle 3 would be 120 degrees, and so would angle 5. Those are what we call, again, alternate interior angles. And I know these angle measures are going to work because 120 plus 60 degrees is supplementary. It creates a linear pair. It creates a line. So these are congruent, these two are congruent, and this should equal 180 degrees when added together. Alternate exterior angle measures. So they're on the outsides of our transversal on alternating sides. So if I said this was 60 degrees, this one would also be 60 degrees. If I said this was 120 degrees, so would angle 1. These are congruent. So the difference, these are on the inside, these are on the outside of our parallel lines. Corresponding angles. This is the one that I find is the hardest to remember. If a transversal intersects two parallel lines, then the corresponding angles will be congruent. I like to remember this one as located on the same side of our transversal, but one interior and one exterior. So let's just take a look. I can see that 2 is on the exterior, 6 is in the interior. So 1 is on the outside, 1 is on the inside, on the same side of our transversal. So we call that corresponding. If I said this was 60 degrees, this one would be 60 degrees. If I said this one was 120 degrees, this one would be 120 degrees. If I said this one was 60 degrees, because these are vertical, angle 4 would also be 60 degrees. And if I said angle 3, well, compared to angle 1, that's vertical angles, and vertical angles are congruent. The corresponding angle would be 7, which is also 120 degrees, again proving the vertical angles here. So now if we take a moment, we can see that there actually is a relationship between 3 and 6. We can also see that there's a relationship between 4 and 5. If you were to add those together, that adds up to equal 180 degrees. They're supplementary, which leads to the last angle pair. Same side interior angles and same side exterior angles. So if a transversal intersects two parallel lines, then the same side interior angles, these are not congruent. These are what we call supplementary. They have a sum of 180 degrees. Two angles that add together to equal 180 degrees. So if I said that angle 3 was 120 degrees, then angle 6 also has to, not equal 120, it would have to be supplementary to 120, making angle 6 60 degrees. And before I was filling this out as if it was alternate interior, but I could have just found angle 6 before writing angle 5. So these would be supplementary to each other. These are supplementary to each other. Let's take a look at some examples. So complete the diagram for all the missing angle measures. Which theorem or postulate did you use? There are multiple ways of doing this problem, right? I'm going to show it one way, but you can do this many different ways. Looks like we are given an angle measure here, 105 degrees. I could use vertical angles with angle 7 to say that these are congruent. This will also equal 105 degrees due to vertical angles. Knowing angle 7, I could find angle 5 because these are alternate exterior angles with these parallel lines cut by this transversal. So angle 5 would also be 105 degrees. I could have found angle 5 by saying these two are corresponding. That would have also worked. Knowing angle 7, I could find angle 3. These are called, again, corresponding angles. But I could have also used the vertical angles with angle 5. I could have said that these were alternate interior. That would have worked as well. Let's move on to maybe angle 6. 7 and 6 are corresponding. One is on the inside, one is on the outside of our parallel lines cut by that transversal. You could have said that this 105 degrees is alternate interior with angle 6. We could say that 105 degrees and the angle 4, because they're in our parallel lines cut by this transversal, these are same side interior angles. They're not congruent, they are supplementary to each other. So this would have to be 75 degrees. Just fill this out. So then we can find even angle 8, because again, between these parallel lines cut by this transversal, angle 8 is supplementary with angle 4. They're same side interior angles. We could use angle 4 to find angle 2. These are corresponding, and corresponding angles are congruent. But you could have also said that 2 and 5 were same side interior or supplementary. Adds up to 180 degrees. And last, angle 1. These are vertical angles, 1 and 2, and vertical angles are congruent. You could have also said 1 and 4 are alternate interior angles, therefore congruent. You could have said 1 and 8 are supplementary to each other. They are linear pairs. You could have also said that 1 and 3 are same side exterior angles with these parallel lines cut by that transversal, meaning they're supplementary. So many ways of solving that problem. Angle 2. Name the angle pair shown, solve for the missing variable, check your solutions by substitution. So first we got to figure out what is this special angle pair. I'm sorry, this came out a little faded. This is a 14x minus 5 degrees, and this is a 13x. When looking at this problem, it looks like they are on the interior, but on alternating sides of our transversal, right? So they're on alternate sides of that transversal. So we're going to call this alternate interior angles. These angles are going to be congruent. And for our equation, because they're congruent, we're going to write this as 14x minus 5 equals 13x. Right? They are equal to each other. They're congruent. So let's solve for the missing variable. I'm going to subtract 13x from both sides. What I'm left with is x minus 5 equals 0. I'm going to add 5 to both sides. So x must equal 5. Now a lot of people stop here. Right? You think that you got your answer. It must be 5. I'm done. Must be 5 degrees. But please be very careful. You must substitute this variable back into each expression to determine whether your answer is correct or not. So we can take our 14, multiply it by 5, and take away 5. So 70 minus 5, which will give us 65 degrees. This other one should equal 65 degrees. So 13 times 5, substitute that into a calculator, or plug it into a calculator, you will get 65 degrees. They are congruent to each other, therefore I know that this is a good answer. I hope this helps.